So, when you're dealing with standard streaming video, a little buffering or lag is just the cost of doing business, right? You just accept it.
Yeah, pretty much.
But today, we're taking a deep dive into a piece of hardware that completely eliminates that reality. It's a ZeeVee Z4KF2XS-E fiber encoder, which you can get via HDTV Supply.
Okay, let's really unpack this because, even if you aren't currently building a multi-million-dollar sports bar or a mega casino, the sheer data-moving power of this tech is absolutely mind-blowing.
It really is. And to understand why a single unit costs over $1,000, you first have to look at the massive data bottleneck it solves. What's fascinating here is its ability to stream uncompressed 4K video at 60 frames per second.
Right, that's the 4K P60 4.4.4 spec, right?
Exactly. It handles that 4.4.4 chroma subsampling over a 10 gigabit fiber connection, and it does all of this with zero frame latency while being totally locked down by AES 128 and HTTP 2.3 encryption. Okay, wait, I want to jump in on that zero frame latency thing, because that's like having a conversation with someone in the exact same room versus, one of those laggy, frustrating internet video calls we all hate.
Yeah, that's a good way to look at it.
But I have to push back a little here. Is an uncompressed 4K signal actually noticeable to the human eye? Or is this just, spec sheet bragging?
Well, in your living room, you probably wouldn't notice, but in professional environments, compression is basically the enemy. Think of video compression like a translator at the UN.
Oh, okay. Like there's a built-in delay.
Right. Even the absolute fastest translator takes a second to hear a phrase and repeat it in another language. That processing time creates lag because a computer is actively guessing which pixels it can throw away to save space.
Wow, okay.
Yeah, so uncompressed zero latency means the camera and the screen already speak the exact same language. There is zero processing time.
That makes perfect sense. So in a live event or when you're synchronizing a massive array of displays, even a microsecond of that translation lag can just ruin the illusion or mess up a critical broadcast.
Exactly.
Uncompressed means the moment the action happens, it's instantly and flawlessly on the screen.
Yeah.
And because it's running that AES 128 and HDTP 2.3 encryption, that raw feed is mathematically scrambled.
Yeah.
Right? So nobody can intercept or pirate a high-value broadcast.
You nailed it. It's totally secure.
Okay, so you've eliminated the lag and you have this flawless, secure 4K picture.
Yeah.
But a heavy, uncompressed signal like that has to degrade quickly, right? Like, how are they moving that massive amount of data across an entire stadium?
That is where the fiber optics come in. So if you're using multi-mode fiber, which bounces the light signals at multiple angles for shorter runs, you can push that signal 300 meters.
Which is already a huge distance.
It is. But if you switch to single-mode fiber, which shoots a single laser straight down the core to prevent signal loss, you can send that exact same uncompressed 4K signal a massive 10 kilometers.
Here's where it gets really interesting to me. It's not just sending one single picture that far. This device supports multi-view for up to 19 different sources at once, and it can drive video walls up to 15 by 15 displays. Wait, a 15 by 15 wall? That's 225 screens.
Yeah, it's huge.
Who on earth actually needs 225 screens connected by 10 kilometers of fiber optic cable?
Well, you have to think about the scale of modern infrastructure. This acts as the nervous system for a sprawling university campus, a massive corporate headquarters, or, like we said, an entire sports stadium.
Right, of course.
They need to route dozens of different video feeds to hundreds of displays flawlessly. And it's incredibly practical at the source, too. It features a USB-C input with 60-watt charging and a built-in 1 gigabit utility Ethernet port.
Oh, I see. So a technician in the stadium control room doesn't need a massive hub of power bricks and separate network cables. One single USB-C cable powers their laptop, puts them on the network, and handles all that AV heavy lifting at the exact same time.
Exactly. It cleans up the control room completely.
So what does this all mean for the bottom line? Today's price is $4,460, down from an MSRP of $1,825. But at that price point, you aren't really paying for video quality, are you? You are buying an insurance policy against a single microsecond of lag, ruining $1 million live broadcast.
Yeah, it's essentially commercial-grade invincibility. You are buying absolute reliability and scale that simply cannot fail when the stakes are highest.
Which leaves you with something fascinating to ponder. As this zero-latency fiber optic technology inevitably gets cheaper and trickles down to the consumer market, how will it completely revolutionize the way you design your own living room and interact with digital spaces?